Tell us your name and tell us about your project.
My name is Nick Dunaway, and during the late 19th century, I was working closely with Albert Michelson and Edward Morley as they tried to prove the existence of ether, um, which was a substance that electromagnetic waves supposedly traveled through. At the time, physicists believed that just as with sound waves use air or waves in the ocean use water, a medium is required for the waves of light to move through space. The medium light was supposed to travel through was this luminiferous ether. In order to conduct our research, we used an interferometer, which was invented just a few years prior in 1881 by Michelson himself. The interferometer is a device that is used to this day for testing prisms and lenses, measuring index of refraction, and examining the tiny details on surfaces.
What were you trying to do or find?
My partners and I were trying to prove the existence of this luminiferous ether. Theories at the time suggested that ether formed the absolute reference frame to which the rest of the universe was stationary. Our idea was that by measuring the speed of light in different directions, it would allow us to measure the speed of the ether with respect to the Earth. Michelson and Morley were able to measure the speed of light by looking for interference fringes between the light that had passed through the two perpendicular arms of their interferometer apparatus. This would occur because the light would travel faster along an arm if it was oriented in the direction the ether was moving in, and therefore slower if oriented in the opposite direction. Since the two arms were perpendicular, the only way that light would travel at the same speed in both arms would be if the instrument were motionless with respect to the ether.
Where did the project or experiment occur?
Our experiments occurred at Case Western Reserve University in Cleveland, Ohio, back in 1887.
What other significant events were happening around the world at that time?
Um, the year prior, in 1886, Nikola Tesla formed the Tesla Light and Manufacturing Company in Rahway, New Jersey. And during the first few years of electricity distribution, Thomas Edison's direct current, DC, was the standard in the United States. However, Nikola Tesla had discovered a way to create a system for generation, transmission, and the use of an alternating current instead of direct current. Tesla had previously been employed under Edison, interestingly enough. However, his brilliance was underestimated. Edison dismissed many of his ideas, including one on AC power. Um, Tesla partnered with George Westinghouse to commercialize his AC system, and the war of currents, so to speak, began between Edison and Tesla. Edison fought fiercely to keep his DC current the standard because he didn't want to lose his patent royalties. He even went so far as to start a campaign to destroy the use of alternating current by spreading false information on alternating current, like fatal accidents from it, and he lobbied against the use of AC in state legislatures.
Who else was involved in your project?
As previously stated, Albert Michelson and Edward Morley were the main two that worked on this experiment. Later on, though, Hendrik Lorentz made the contributions to the research when he found that the negative result by Michelson and Morley was caused by an effect of contraction made by the ether on their apparatus. Lorentz then introduced an equation to find this contracted length.
And what was your role in the project?
My role in the project was to tend to the apparatus before each test run, making sure the arms and everything else were where they needed to be for our result to be as accurate as possible.
And what impact did your project have on the physics community?
We were able to very accurately measure the speed of light developed the interferometer device, variations of which are still being used today. And later, Michelson developed the stellar interferometer, which measured the diameter of stars according to the angle. Because of our discoveries, Lorentz work, along with others, a new branch of physics emerged by the hands of none other than Albert Einstein with his special relativity theory.
Some would call the experiments you performed as failures, considering the hypothesized result on the ethers was not found. Why would you call them a success?
I would call it a success because we discovered some very important things as we conducted our research. For example, Michelson invented the interferometer and calculated the speed of light. And a failed experiment is just one where nothing was learned. We found out that ethers did not, in fact, exist, and that is success for me.